All right, here we are in the subdirectory, and we're going to look at some of the files and try to get this thing off the ground. First of all, we're going to have to bring up a terminal window, which I already have. You can actually bring up a terminal window by right-clicking and saying Open in Terminal. At least that works in Linux Mint. It may or may not in your version. Anyway, if I bring up a terminal, here is the terminal. I was working on it earlier. You can see there's the files. First of all, you need to make all the script files executable. User plus x star.script. Okay, and you probably want to make the mumps files executable too, so star.mumps, because they don't come executable. Okay, so that should pretty much do it. Now, there's a variety of files in here. Let's look at the main indexing file. First of all, look at osu.medline. That's the database file that we're going to be using. The file that actually runs all of the indexing operations is index.script. So vi index, I'm using vi obviously. You can use any editor there. I like vi index.script. And there it is. It's a standard bash script. That's what the first line tells it. It tells the system to execute a bash shell. This is just normally a pound sign, of course, introduces a comment. And this line is a comment. This is a comment technically, but because of the exclamation point pronounced bang in Linux, it tells it instead to run a shell. I use that in my mumps, as you may have noticed. So this is when it was last modified, which was last fall. Now the first command down here adds dot to your current path. Path is where in Linux it looks to find a program. When you type in a command, it looks in path to find the directories where it should look for that command or program. By default in Linux systems, the current directory is not part of path. And what I'm doing here is adding it. Dot refers to the current directory. So that adds to path. It'll go away next time you log in. But it adds to path the current directory. Now clear clears the screen. So everything will go off the screen. Echo is a print statement. It writes out, in this case, document index file, and the back quote. Notice that's a back quote. It's the lowercase of the tilde or squiggle character. The word date in there is actually the name of a program. It causes the program to be run and the result of the program to be inserted at this point. So what will be is document indexing, and then there'll be the date. Will actually appear where back quote date appears. And you notice it's in double quotes, and more echoes and so forth. Comments, decorative comments. This gives you an example of how it's intended to be run. It's supposed to be index.script, and then you give it the number of documents it should process. For experimental purposes, you don't want to process all 300,000 of them. You need to process a subset. So anywhere between 1,000 and 10,000 is probably the number you want to deal with. If the number you're dealing with is too small, you don't get enough statistical data to index properly. If it's too large, you're going to be sitting there forever waiting for it to run. So there's a trade-off. So anyway, this comment here, if you typed it as index.script 10,000, that means to process 10,000 documents. The second argument on it would be the name of the database. By default, we assume it's osu.medline, but it could be something else. All right. Don't want to really dwell too much here because you're probably never going to change this anyway. As we go down here, this is a bash if statement. Bash is kind of cryptic, but it's asking if you typed index.script, that's $0, $1 would be the first parameter. If it's equal to a minus or dash question mark, you're asking for help. And what it does is it writes out some help script and exits this script. It quits the script, and you would go back to your invoking console terminal. If $1, the parameter, the first parameter on the line, is empty, it means you didn't supply a number of documents. It's going to default to 1,000. Max docs is a bash variable which tells you how many documents we're going to process. And if you don't put anything down, it defaults to 1,000. Otherwise, it will take the value you put in. It doesn't check it, by the way. So if you put in fluffy, we're going to have problems later on. So it better be a number. I should probably, for completeness, check to make sure it's a number, but let's assume you've behaved yourself and you've put in a proper number. Fi ends the if. If the second parameter is present, that means that you're giving a different database. This is asking if it's not present. If it's not present, OSU becomes a value of dB, bash variable dB. Otherwise, it's the value you gave in second parameter. You export dB and it types it out, and it also writes it into a variable called, or excuse me, it echoes into a file, a tiny file, which is the prefix. dB prefix. That's a tiny file that's being created, and the contents of it will be the value of $dB. Next thing, we're getting started with the output. First thing is you zero out, or when you copy /dev/null to a file, that in this case concatenate. What you /dev/null is an empty file. You can write to it, and everything you write to it disappears. If you copy from it to something, whatever you're copying it to empties. So nohup.out is a file created by nohup. Nohup is a program which will allow you to run other programs and scripts and log off. They'll stay running in the background, and any output that would have come to the terminal goes into a file called nohup.out. Now, if you're running things in nohup, and we'll show it later, there can't be any console input. All the input must be in the file that's being run. So anyway, that clears out any previous values. The problem with nohup.out is it accumulates. Every time you run a program under nohup, it adds to nohup.out, and so we're cleaning it out before we use it. Then we're erasing a bunch of files. These are the database files, key.dat, data.dat, and so forth, that are used in I'm using the native mode of Mumps database. There's several different databases in my version of Mumps. The native mode is the fastest. It's also the most fragile, but it is faster. So we're clearing them out. So just in case there was a previous run, you do not have the debris from the previous run bothering this one. That can be a problem in Mumps. People forget that these things they're storing are still there the next time they run, and things tend to not start fresh. They accumulate. So anyway, getting rid of the database is one sure way of getting rid of all of the previous data. The kill command is the other way, but this is much quicker. Then it gets rid of any other files that may exist from previous runs, .text files, .sorted, .temp. There's our old results. The -f on rm is force. It means do it. Don't argue about it. Anyway, the first program we actually run here is starttime.mumps. And the purpose of starttime.mumps is to tell us is to make a marker, to write a file out that gives us the starting time. And I'll go out of here and I'll look at starttime.mumps. And it's very simple. He has the # bang user/bin/mumps because mumps is running as a script file, as a shell itself. And what it does is it opens a file. Everything's abbreviated here. O means open. It opens a file to unit number 1. The file name will be starttime. And new means it's a new file. If it previously existed, the old existence is erased and a new one is created. We switch to unit number 1 and we write out the time of day. This is the Unix or Linux time stamp with a new line character, close one and halt. So if I bring up Mumps, you'll see what $ZD1 looks like. It's the number of seconds since, January 1st, 1972 or something. All right. Back to the index file. So that number is out there. We'll difference it at the end with how much time and find out how many seconds the whole thing took. All right, so we've got that out there. We check to see, we ask if there is a file, whatever you typed in for the database or defaulted to OSU. It's probably OSU. This value here is probably OSU.converted. If it exists and titles.list exists, it says forget about them. We already have the files. We don't need to convert them. Otherwise, we need to rebuild the input files. The input files take a long time because we take that OSU.medline database and we massage it. And that's what we're doing. So the first program we run is map.mumps. And you can see that's a mumps program, and the input to it is going to be osu.medline or something else, but it's probably osu.medline. Okay, let's go take a look at that. First of all, we should look at osu.medline. Using more here, we'll see a page of it, and that's what it looks like. That's the old National Library of Medicine standard format. A lot of their material is still formatted this way. Each abstract begins with the line stat-space medline. And then it's got a lot of medical mesh headings. We call these mesh headings, which tell us the content of the document. They're the indexing terms that have been used by National Library of Medicine to index this particular document. TI tells us the title of the document. Now, there's some things that are missing here, which is also the journal and other things. They've already been processed out, but the title is the actual title of the document. And you see these are all in very fixed formats. Then AB starts the abstract. So here's the actual abstract of the document. And these all begin in fixed columns, as we'll see in a moment. Now, I am going to, I meant to hit the wrong, so here's a second document. If you noticed here, these documents are separated. I've skipped forward one more. At the end of an abstract, there's a blank line, and then you get the med line again. Now, here's another document. I think I'm on about the third document. This is smaller. So we've got a bunch of the medical subject headings, not interested in them. You can look at them and you can compare them, but I'm not interested in them at the moment. I am interested in the titles, and I will be interested in the abstracts. And I want to know where they are in the original. This is the original file. So that's what the file looks like. We've got stat medline, we've got MH, TI, and AB. We've got to process against those codes. So I'll get out of there and I'll map.mumps, the first processing program. And you can see it's going to do a few things. First of all, it tries to find out how many documents are we processing. And what it does is it runs a Z function in my version of Mumps. Other versions may or may not have this function. Z functions are implementer defined. It runs what is the C function getEnv. GetEnv gets the value of an environment variable. MaxDocs is an environment variable. It was put into the environment by that shell index.script. It was that export command, if you recall. The export command put into the environment MaxDocs, and MaxDocs has a value. And that value is being extracted and it's being put into the Mumps variable M. For some reason it doesn't exist. It defaults out to some huge number here. What is that? A million, I guess. It then opens to unit number 1, titles.list. It's going to be a text file, and it's new, which means that previously existed, it's erased, and a new one is created. And then it destroys any previous instance of the global array map, up arrow map, that gets destroyed. There isn't any at this point, too, because we deleted the database files. But anyway, if they did exist, it would delete them. We set, this is going to be a document counter, because we do all our documents are going to be referred to by their relative number, 1, 2, 3, 4, document 200, document 300. So we use just a document number, an accession number it's often referred to in libraries. Okay, forever, so 2 blanks there if you've been watching along in the Mumps videos. Because there's no arguments to the for, you have to have 2 blanks before the do. The do likewise has no arguments, so again there's two blanks. When we come back from the do, we'll find out if D, the document number, has exceeded M, which is the maximum number of documents, in which case we'll quit the for, which means we'll jump down to this close down here, and that'll end the program. Okay, now we're in a block. You notice the dot. The do will invoke the block. Blocks are determined, the depth of the block in Mumps is determined by the number of dots. So the first level of block is 1 dot. You'll notice further down there are 2 dots, which is a doubly indented or a second level of block. All right, we switch to unit number 5, which is the input. The default input, your console input. Now, if you remember from the command, it was map.mumps > sign, and then there was osu.medline. Okay, that means that the what looks like console input is coming from osu.medline. So when we read from Unit 5, we're reading from osu.medline. The first command after that is we set O, the variable O, equal to ztel. Ztel is again another implementer defined function, and what it does is it gives us the current offset in the current on the current file. So if you look at the tel or tello function in C, you'll see that's exactly what you're executing. It tells us what byte number on a file we are at. Files in Linux and Unix are indexed by their byte number. The first byte is byte 0, and the thousandth byte is byte 1000. So this comes back and tells us exactly where in the file we are, that we are about to read. It is the byte number of the file of the line or the byte we're about to read, and then we read. So O is the address in the file of the first byte of the line read right here. So we remember that because we're going to need it because we want to keep track of where these things are in the original file. So we can go back in and pull the original abstracts during retrieval. If $test fails on the read, it means we ran out of input, so we're done. Okay, next we extract from the line we just read the first two characters. That is, beginning with position 1 and extending through and including position 2. We pull those two characters out and we compare them with the letters TI, which is the code for title. If they match, then we will enter the block, the doubly indented block, the deeper block with the do command. And you see the double blanks right there. When we come back from the block, we will just quit. We will move on to the next thing, which would be this line down here, the line with the if on it. So that's the way block structure. So with the do, we enter this doubly indented block, the two dots. When we quit here, we go back up here, we quit there, and we go down to the if. It's kind of messy, but that's how they do it. I've got a short circuit, you'll see, which is a break command, which gets you out of things without going through the quitting apparatus. Anyway, we enter the block. First thing we do is we increment the document number. We got a new title. It's a new document. So the document number is incremented. We switch to unit number 1. Unit number 1 is our titles.list file. And we write out the document number, followed by a space, followed by the first 93 characters, I guess it is, of the title. We begin in column 7, and we go out through and including column 100, if there is one. If the title is short, the 100 doesn't mean anything. We're not writing 100 characters if the title is only 60 characters long. So all of the text in the file begins in column 7. So 7 through 100. 100 is the maximum we'll take. Because we're doing experiments, we're not we're going to truncate the titles. We don't need endlessly long titles. All right, we switch back to unit number 5. So we've written the title out to our titles collection, and we put into the global array map, indexed by the document number D, the offset. Offset is actually set right down here. We haven't done it yet. We haven't gotten this far. Because title is never the first thing in the file. Stat medline is first, and we will not have entered here yet on the first document. On the first document, we'll enter in here first, and offset or OFF is set to O at this point. So anyway, when we're in here, OFF has been set, and it is the value of O that occurred when we read the stat medline. The value of O or off, as it's going to be, is the address in the file of a stat medline. Okay, so when we go back up here, when we were about to read a line, we set O equal to $ztel, which tells us where in the file we are. The first time through, the very first document, the very first line is stat medline. So we will not, this block here won't be entered the first time through. Whoops, this block here, let me get the blocks correct. The title is not it. Instead, what we will do is we will enter here, because stat medline is the actual first thing on the line, and it begins in position 1. It extends out through and including position 13. It is stat hyphen blank medline. They all are that way, and that's where off gets set. We will read other things like MHs and so forth, and AB and whatnot. But the one that where the OFF is set is if it's stat medline, and that is the starting point of a document abstract in the file. That's the number we record in this line right here. So map up arrow map sub D, or document number, is the offset of the stat medline for this particular document, the first line of this particular document. Anyway, after the title is processed, we're down here. If we find that the line has an MH on it, we don't do anything. We quit, we go back up and read. The quit here takes us back up, and we read another line, basically. We'll come back up to the do. D is not greater than M yet. Maybe it is, but it's not yet. We re-enter, we read another line. So if they have MH, we just forget about them. If it's stat medline, we do record in OFF the value of O. And we have to record it here because O is going to change each time we read a line. There's, at the beginning of these, there's a bunch of MHs. So when we get to the title, we're somewhat into the section of text for an abstract. If it's AB, if it's not equal to AB, there's really not much else it could be. We quit. But if we drop down here, it means it is an AB. And what we're basically doing is we're going to keep reading until we get an empty line. At the end of the abstract is an empty line. The empty line signals the fact that we're about to start a new document. So if we're in the abstract part, we keep reading until we get an empty line. When we get an empty line, there's the break, by the way, which kills the do. I don't have the quit in this sequence here. If we run out of text, we break. If the line is empty, we break. In either case, we go back up to the top here and we repeat the situation. So essentially what this file does is it reads up to max docs, say 1,000, 10,000, or 1,000,000 if you didn't put anything down. It reads up to max docs the abstracts from osu.medline. It finds the titles. It writes the titles out to a file called titles.list. And it records in a global array called map for each document, 1, 2, 3, 4, the offset of the stat medline in the original file where the title came from. Okay, so why we want this is that later on when we do retrieval, we want to be able to go back in and get the original abstract and other data associated with this particular document. All right, we're back in the index.script file. So we have looked at map.mumps. It writes out a title list, and it records the offset in the file of each stat medline line, which is the start of each abstract sequence in the original file. Next, we go through a lot of sed commands here. The input is osu.medline or something else.medline. Let's assume it's osu.medline. This is the input, and what we are going to do is we're removing punctuation, we're removing numbers, we're removing hyphens, double hyphens, decimal points where they don't belong. It's basically cleaning up the file, and I'm not going to get into the sed commands because they're complicated. But essentially speaking, osu.medline, a lot of stuff is removed from it, and the output goes into temp.temp. That is the output, the massaged output of osu.medline. Then we go into a program called reformat.mumps. These are all formatting to massage the input file into something that'll be easier to work with, that we can deal with. There's a lot of things we don't want in that file. We're not going to index punctuation and numbers and things like that, and there's a lot of funny stuff in the file we really don't want. So reformat.mumps reads in temp.temp. Temp.temp will come in as though it were coming from the keyboard. It's redirected input in Linux. And the output, you see it's a vertical bar here, so it's piped. The output is piped into sed again, and what sed is doing here is it's basically removing short words from the words that are 1 to 3 characters in length are being removed here at the beginning and at the end. It's slightly different. The result, the output, see the greater than sign, the output will be osu.converted. So when we finish all this, we're going to have a file called osu.converted. That's the one we're going to work on. Temp.temp can be done away with. That's insignificant. So let's look at reformat.mumps. And here it is. Again, it gets the number of documents to process, defaults to 1,000,000 otherwise. This one is also writing titles.list. I didn't notice this until today, so it should be removed. It's redundant. We've already written titles.list. It's very similar to the previous one, is that we do have an open unit number 1, titles.list. We read a line from the input. We run out of input. We're done. If it's a title, there's the TI. Same as before, we increment the document number. We're going to need to do that anyway. It's not the same as before, really, although we did do it before. Here's where we pull off the title, 7 through 100, and write it out to titles.list. This is the unnecessary line because it's already been done. But it does assume that up arrow map D, sub D does exist. We write out, what we're writing out here is we're writing out the offset of where the document begins in the original file, the stat medline. That's the up arrow map sub D is the address of start medline for this particular document in the original file. We write that out. It can be a very large number. A blank followed by the document number, followed by a blank, followed by the text of the line of the title. The title text itself is part of. We're going to index that. So at the first line for each document in our processed massaged file, we'll have the address in the original file of the stat medline, a blank, the document number, a blank, and then there'll be the text of the title. 2048 is obviously overkill. None of the titles are anywhere near that long, but doesn't hurt. Followed by a blank. So we quit that because that was the if statement. And then so if it's not TI, then it must have been something else. If it's an MH, we quit, we forget about it. If it's a stat medline, we will write out a new line character. See the exclamation point? If D, document number, is not 0. What does that mean? It means that the very first stat medline, we won't write out a new line character. The new line characters are to separate each of these massaged documents from one another by a blank line. We don't need to write out a blank line at the beginning because the first one is the first one. It's only subsequent ones that we need to write out a blank line. In other words, if we're processing along and we encounter a stat medline, we're going to write into the output file a blank line, a new line character, which separates what's about to come from what came before it. So each of these massaged abstracts, you'll see them in a moment, is going to have a blank line between it. Except the first, there's no blank line preceding the first, and that's what all that's doing. If it's not AB, we quit. If it was an AB, it does have something on the line beginning in position 7 and extending out only a couple of, about 100 characters, not 2048, but again, doesn't hurt. And then we go into a loop, reading lines in. And if we run out of input, we exit. In other words, that breaks us out of this 4. We don't have to go back up and do all that quit stuff. Break is a quicker way out. If the line is empty, we break. If the line is empty, it means we're at the end of the abstract. We're reading the original file. It still has blanks between the abstracts. Otherwise, we set line equal to lowercase. Z_lower is one of my functions which converts everything to lowercase. And we convert everything to lowercase beginning in column 7 out through 255 is much more realistic. No line is anywhere even near 255. After the line has been converted to lowercase, we write it out, followed by a blank. So what are we doing, really? We're reading them in, the abstracts in. We're writing out the offset, the document number, the title, and then continuously the lines of the abstract. So each document, in reality, is going to be one big giant line in length. And that's what will be in osu.converted. Now, I'm actually going to run it because it has not been processed here. This is a fresh download. And you will, and I'll have to pause the video because it does take a while. Well, it doesn't take that while if I'm index.script. let's say 1,000. Again, this is assuming I'm writing index.script. This assumes that dot is in your path. If it's not, it should be dot/index.script. I put a dot in my path. I'll put 10,000 documents in. And it's, as you see, it started running. It cleared the screen. It says it's rebuilding the database. I'll pause the video at this point. All right, the process finished. Took a little while, and you can see it had started to go on to other things, but I Control-C'd it. You'll notice up here in the first line, I didn't mention it before, there's the date. Well, it starts with Sunday, actually. That's the back quote date, back quote, if you remember that line. So if you want something to appear in your output, use you program to run, and the output of the program to appear, use the back quotes. It's very handy on some things. Anyway, it made it through, and it was about ready to start processing things. What does it look like? OSU.converted is the thing. That's what we created, and that's what it looks like. Each document is a giant long line. Here is the first document. It has wrapped around, but that's the first document. What do we see here? We see, well, 0. That's the offset. It's the first document, the very first byte. It's document number 1. See, there's the document number right here. And the type is binding acetaldehyde to the active site, blah, blah, blah. Notice everything is in lowercase. Short words have been removed. There's no numbers. There's no punctuation. It's been massaged. A lot of the stuff has been pulled. That's the end of the first document. The second document begins right here and goes down through apparently right there. And you see the offset of the second document is at 2401. It's the second document, and again, we have the text. Then the third document begins right here, and you see the offsets start to get rather large because the offsets will increment by the total amount of text. So space through several of them here. Here is document 59. It starts at 61,292 bytes into the file. So every one of these is just now been reduced to a big, giant, long line. And I'm going to process these big, giant, long lines in the coming text.